distributed storage, distributed processing of very large amount of data. The distributed storage and distributed processing. So distributed storage, which achieved via HDFS, Hadoop Distributed File System. Distributed processing, which achieved via the excellent component, which is called as MapReduce. So HDFS and MapReduce, these are the two core components of Hadoop. So in addition to that, it built on commodity hardware. The Hadoop which is running in the top of normal commodity hardware. It's another excellent advantage. A normal PC is enough for managing Hadoop distributed file system as well as MapReduce. So it's another advantage of Hadoop environment. So please see the picture. In the year 2006, dog cutting working in Yahoo. So Yahoo and another one company, they are using Hadoop. 2007, additional two companies added. 2008, even Google also following Hadoop. Actually, dog cutting studied Google white paper, GFS, and then they create Hadoop. On 2008, Google follows Hadoop. 2008, 2009, 2010, in 2022 and 2021, 99.9% companies, their base framework, which is made up of Hadoop. So Hadoop is a core architecture. The founder of Hadoop is dog cutting and Mike. So the name began Hadoop because of the dog cutting son. They are having an elephant toy. The toy elephant name was Hadoop. So they fit that same name to their development tool. So the same logo, that is toy elephant, yellow toy elephant, as well as the name was Hadoop. Just name behind that. So always all are more familiar about the overview. So the basic characteristics, it's scalable. If any number of users request the data or processing the data, it's automatically scale up and provide the service. It uses a commodity hardware, so it's very cost effective. It provides efficient and flexible service. Always the greatest advantage of Hadoop environment, it's fault tolerance. If user requested data, if the server fails, it isolates that server and then provide the information from other server. So always the replication was maintained. So it's always fault tolerant. Then easy to use. It's built up with the help of Java, Python, as well as Ruby on Rails. So even all those famous companies, they are using Hadoop for their core framework. Samsung, eBay, Intel, HP, FB, Twitter, Autonomous. So all those companies, they are using their base fundamental framework in Hadoop. Hadoop is a base framework for managing larger amount of data. It's purely open source. It's in Apache license. When Hadoop, if your data, lots of unstructured, if the data was having lots of unstructured data, then you can go for Hadoop. So it can perform the task in a parallel manner. The batch job also acceptable. Yeah, it uses a commodity hardware for cost was less. There are two core components in that Hadoop environment. The first one, which is named as Hadoop HDFS. The second one, which is named as Hadoop MapReduce. So Hadoop, which is comprising of two core components. One which is named as HDFS for storing data or managing data. The second one, which is called as MapReduce for processing data. First one called as HDFS for storing data. The second one named as MapReduce for processing data. So HDFS for storing data, MapReduce for processing data, Hive. So why Hive is needed? So HDFS and MapReduce is enough. But in MapReduce, the entire thing which is written in Java programming. The entire thing was written in Java programming. So always for managing data, each and every organization, they are holding database developers or DBMS engineers. Something like they are always ready for SQL queries. They are always ready for writing SQL queries. But here, MapReduce, whether you write a program in Java or Python. So always the companies, they are replacing all their database engineer with a programmer. So it's very tough. So in that situation, so Facebook, in that situation, Facebook launched a new technology. There is a middleware framework named as Hive. So user can write a Hive QL, that is Hive query language. User can write something like SQL. User can write Hive QL, the Hive framework, which automatically generate a Java program and running on MapReduce. That's fine. So writing Java program is typical for database engineer. So in that situation, the Facebook introduced a new framework named as Hive. In that framework, user can write a Hive query language. The Hive query language, Hive query language is something like a SQL, structured query language. Something like create database, create table, insert table, something like that, same. So the query which converted into Java program and then which running on MapReduce. So same thing which is happening. So that is Hive, a SQL-like syntax with a meta store to allow SQL manipulation of data processed on HDFS. Epic, it's a top-down scripting language for manipulation. It's a Latin, something similar way. So many of the organizations, something like Google, they are using a programming language which is called as Latin. So always all those their employees, they are working on Latin, but Hadoop supports Java as well as Python. So Google introduced a framework named as PIC. So PIC is a framework which used to convert Latin program into Java. PIC is a framework which used to convert Latin program into Java. So which directly rely on MapReduce and then working on that environment. Hbase. Hbase is an excellent tool for providing not only SQL, non-sequential data store, non-sequential database store. Normally we are using row-based approach. Here the approach was changed into column-based approach. Hbase, the complete approach was changed into column-based approach. So these are some of the excellent ecosystem, excellent core frameworks which are running in the top of Hadoop. HDFS for storing data, MapReduce for processing data, Hive query language which converted into Java, PIC Latin program which converted into Java, Hbase, a not only SQL database or non-sequential data store, a column-based approach or graph-based approach which converted into Java. Which running into Hadoop. Hbase which don't need MapReduce, which directly rely on Hadoop environment. So this is a Hadoop ecosystem. So now we are entering into first part, HDFS, Hadoop Distributed File System. Hadoop Distributed File System. So stores files in blocks. So it's, for example, it split the file into smaller pieces and store it into several data nodes. If user need, which combine everything and give it to user. In addition to that, if one node fails for solving the issue, it replicates the data into number of blocks. Normally, HDFS architecture, which is follows name node and data node, something like a master-slave architecture. A name node is a master who choose to hold a complete metadata where each and every blocks are stored, which direct access to files to HDFS. Secondary name node, if name node fails, what will happen? So there is a secondary name node. It's not a hard failover, so it's immediately not acting as a name node, but it maintains a copy of name node. So data node, which perform file creation, replication, deletion, read, and write activity. Entire thing which performed by data node. So I'm giving a small example. Please see the picture. HDFS example. The basic example of HDFS, please. So user can put a file. Please listen carefully. So user can put a file. Yes. The file which comprising of 3 blocks. Block 1 for yellow color, block 2 for rose color, block 3 for green color. So the file which comprising of file is split into 3 pieces. Block 1, block 2 as well as block 3. Now the name node which replicate the byte. Yellow block is stored in data node 1. So name node, it maintain a metadata. Yellow block is stored in data node 1. Okay. Rose block is stored in data node 2. Yes, good. Then green block is stored in data node 3. Yes, good. Now create. Now the basic replication factor of this HDFS. The basic replication of this HDFS was 3. So now the each and every block which replicated thrice. So yes, first block, yellow block, data node 1, 4, and 6. So 1, 4, and 6, which is updated in the meta table of name node. So a system which comprising of 1 name node and 6 data node. So a file was split into 3 pieces and distributed into environment. Now the rows block, which replicated into 2, 3, and 5. So 2, 5, and 3. So metadata was updated. Now the green node, which replicated into 3, 2, and 6. 2, 3, and 6. So now the file was replicated in all those locations. So user can submit a file. The file is split into 3 pieces based on the block size. Yeah, normal block size was 64 MB or 128 MB. So the block was replicated into thrice of each and every data node. Now user request a file. Read a file. So the request was sent to name node. So name node, which returned yellow block from data node 1 and rose block from data node 2 and green block from data node 3. Yes, now the data was received from all those 3 blocks. If data node 1 fails, then automatically what HDFS did is it can provide the data from data node 4 and replicate it from data node 5. I am repeating the same again. If data node 1 fails, then immediately there is no block, yellow block in data node 5. Now immediately which respond from data node 4 and replicate to data node 5. That's fine. Respond from data node 4 and replicate from data node 5. This is what HDFS was running. So it can process. What's the advantage? So if read time equal to it transmitting data from 3 PC. So transfer rate into number of machines. So if your transfer rate is 100 Mbps, it transmitted from 3 machines. So it can transmitting data in 300 Mbps speed. So that's the greatest advantage. If you are streaming data in a very, very fast manner. So that's the advantage of HDFS environment. The file was split into smaller pieces and stored into different environment. And then if user request, they can collect the data. Even a normal commodity hardware is enough for creating this HDFS environment. It's another advantage. So HDFS shell command. So normally created all those commands. So it can create, copy, move, delete. Even for the administrative command, something change the ownership, change the group, change the permissions, etc., etc. Yeah, it can also support MapReduce. Just for small overview on MapReduce, then we are entering into Hive and small demo on Hadoop too. So MapReduce, yeah, HDFS for storing data, MapReduce for processing data. HDFS for storing data, but MapReduce for processing data. So MapReduce, even for which running on 3 mode, HDFS which running on 3 mode, standalone, pseudo distributed, and fully distributed mode. So standalone in a single PC with single JVM. So individual JVM with single machine for pseudo distributed mode. If you are each and every PC with the individual JVM, but with a separate machine. So it's a fully distributed mode. So we will try in standalone mode of single node Hadoop installation. Yeah. The core services. running behind Hadoop, which is called as name node, secondary name node, data node. So name node, which is acting as a master. If name node fails, which can recover data from secondary name node, data node, which is acting as a slave for processing your data. In addition to that, there are 3 additional services: resource manager, application master, and node manager for performing the job in an efficient way. So this is a basic HDFS architecture. Name node and data node. If it's MapReduce architecture, master and slave, application master and node manager. Application master split the data, node manager can process it. So name node can split and store a metadata, and data node which stores the data whenever requested, it can provide the data. So it's a 2 core component, HDFS and MapReduce of Hadoop. Yeah, the basic operations of HDFS. So name node, which can split the data and then store it into data node A and C, A and C, A and C, which replicate the data in thrice. So the basic replication factor was 3. So user, it can store a metadata. Yeah, the secondary part, the first part for HDFS, the secondary part for MapReduce, it's the heart of Hadoop. The core component was MapReduce. HDFS and MapReduce are 2 core components. Without HDFS, without MapReduce, none of the framework can run. So Hadoop, the 2 basic components or 2 fundamental components are heart of Hadoop, which depends on HDFS and MapReduce. So it's a basic programming model which is run in Java, Ruby, and Python. Ruby on Rails. So it's parallel processing environment. The core functionality is one for mapping, another one for reducing. Yeah. So it's a basic example we will discuss later. So you are entering into the basic analysis in the big data. So even for think about situation, this is a small website. So how to process big data era? So even updating all those environments very typical. So this information, this information, this information, this information, this information. So something, whatever the information was changing, or something like advertisement or something news or some new updates or some explore cities, something like that. So only this information was updated. So always the website which comprising of all this information, but I will update only this box. So just I will send a JSON file, JavaScript object notation or NoSQL file to update this information only. All those informations are similar like that. So just this page only update. That's a big data error. Or just process the data from this environment and you can update based on the behavior, of the customer. So massive data, you can use data analysis and provide the insight data. Massive data, you can perform the excellent data analytical tool and provide insight data, whatever data. The key success, it provided in a timely manner and cost-effective analysis. So even I'm putting my WhatsApp status as raining. In a fraction of a second or in 2 seconds, it displays the raincoat or umbrella advertisement, then only it's read. After 2 hours, it displays the umbrella and raincoat advertisement. I won't purchase, I won't place order. So timely and cost effective, it's very, very essential. So data analytical engine, time is a major factor. It can process data in an efficient way. In addition to that, it uses a normal commodity hardware, the cheap hardware, something like effective cost utilization. So Hadoop ecosystem, HDFS and MapReduce. In addition to that, PIC for PIC Latin, Mahout, it's like a driver of elephant. So it can manage a big data. Hive for Metastore, Hbase is an open source non-relational distributed database. Scoop, Zookeeper. So these are some of the excellent tools for managing Hadoop distributed file system. So HDFS, MapReduce, Ampari, Pick, Mahout, Hive, Hbase, Scoop, and Scoopkeeper. Yeah, there are each and every organization. They are creating their own tool. Each and every organization, they are creating their own tool for running in the top of Hadoop environment. So it's a Hadoop ecosystem. Please listen carefully. It's a Hadoop ecosystem. So HDFS is a core. HDFS is a core, a distributed processing environment, YARN or MapReduce. It's a MapReduce framework. So HDFS and MapReduce. Hbase is a column store. So without MapReduce, Hbase works. Hbase is directly rely on HDFS. Hbase, which directly rely on HDFS. So Hive, statistical tool or connector, machine learning tool, Mahout. Mahout is a driver of elephant. Pick scripting, Pick Latin tool, OCO. So all those tools which running in the top of MapReduce. So HDFS, MapReduce, and then all these framework. So Hbase only directly running on HDFS. Zookeeper is a controller. It's a coordinator for every activity. So Flume log analyzer. So whatever action which will happen in HDFS environment, a log file is created via Flume. Soup is a data exchanging tool. Then Ampari, it's monitoring, provisioning, managing. If you are deploying Hadoop, then you can collect fee from your customers. So in that situation, you can use Ampari tool. It's excellent monitoring and metering tool. So this is an excellent framework, excellent open source framework, which provided by Hadoop. So all those things, which is termed as Hadoop components or Hadoop ecosystem. So the core component is HDFS and MapReduce. In the top of that, all those components which ones. Yeah, just for a small overview on big data as well as HDFS and MapReduce. Then we are entering into small demo or small little comments on how to create a single node Hadoop and HDFS and then Hive and Hbase. So some advantages. So moving computation is far better than moving data. Moving computation is far better than moving data. Then it runs on commodity hardware. It uses master-slave architecture. So it handles all types of node failure, even live heartbeats. So it handles assigning tasks to nodes, a rack awareness between nodes. Please read the first line again. Yeah, it's a core. Moving computation is far better than moving data. So if you are having larger amount of data, the 100 GB of data, we split it into 100 machines. So all those 100 GB of data are received into one machine and processing. It's very typical. So I write a small program and share the small program to all the 100 PC. 100 PC process that small program for their 1 GB of data and then return the result. It's very easy. So that's a theme of Hadoop. That's a theme of MapReduce. So moving computation is far better than moving data. So the computation, you are writing a small program, that is computation program. That program which is distributed into all the machine and processed separately, and then result was written. So moving data is typical. So the computation was moved to all those machines and processed and returned the result. It can use a commodity hardware, a normal PC. There is no need for separate server. A normal P4 machine is enough for processing Hadoop environment. It uses a name node data node. That is something a similar master slave architecture. If one node fails, that is a no problem. It can use a methodology called as live heartbeat. So it can monitor a heartbeat of each and every machine. If one data node fails, immediately which replicate the data into other and then retrieve the information. It can handle assigning the task to node. Automatically, it can manage the task assignment, replication, creation, and all those things. It has rack awareness between node. So programmers only need to concentrate on getting business value. They can thinking about their logical idea. They won't think about parallelism as well as how to manage the data. So all those things are managed by this excellent tool named as Hadoop. Anyway, do you think Hadoop is a golden bullet that solve all kind of problem? The answer is no. It's not suitable if the data was too small. Not suitable if there is dependency between data. Not suitable if job cannot divide it into smaller chunks. Not suitable to process for real-time and stream-based processing. So anyway, Hadoop, which can perform excellent way, anyway, it's not suitable for some other area. Some limitation is also there. So even Aadhaar card, the current complete Aadhaar card project, which rely on Hadoop environment. So complete Aadhaar project, because it's a larger amount of data, it's unstructured data, even your fingerprint, your home address, your photos, everything was stored in a single file. So that's managed via the excellent tool named as Hadoop. So even it's acting like a human brain. So there are numerous number of job opportunities. Currently, each and every organization, 99.9% of organization, they are depending on this Hadoop. So there are numerous job opportunities: administrator, Hadoop developer, scientist, data analyst, etc., etc. So cost saving, time saving, social media listening, as well as gathering smart data, customer gathering, market insight, business intelligence, innovation. This is a basic importance of big data. So top industries, retail, finance, manufacturing, IT industries, as well as professional sectors, their growth rate was high for information security analysis, management analysis. So all those data scientists, their growth rate was increased in a rapid manner. So even in 2022, the growth rate was very, very huge. So top 3 technologies which is dominating this data analytics, which is called as market intelligence, because cost is a major factor. So always every company, they need a revenue. So market intelligence, business intelligence, and secret intelligence, which completely depends on big data management and data analytics. Most of the people don't know what to do with all the data that they already have. So actually get big by starting small. So focus on business impact. So start with try again. Then at last big data, which provide a smart data to you. Big data is not big if you know how to use it. So you can extract the smart data from the large amount of big data. So this is a small overview of what is big data, then how to extract the data, and then what is Hadoop, then the 2 core components HDFS and MapReduce. The 2 core components HDFS and then MapReduce. Then at last we are entering into this basic for creating a Hadoop cluster and then create HDFS environment, MapReduce environment, Hive as well as Hbase. So very easy, only for 3 or 4 steps. So via a Linux PC. So the basic procedure for creating a Hadoop cluster, a single node Hadoop cluster, or otherwise multi-node Hadoop cluster. That's not a problem. So first, just take a PC or virtual machine. I'm installing an operating system which is named as CentOS. So anything else? So anyone Linux operating system, that's not a problem. So install an operating system, CentOS. So step number one, if you are creating multi-node process, in that situation, one node which acting as a master, or other node which acting as a slave. Only for 10 more steps. So all these steps are very easy. So please listen carefully. So create a Hadoop cluster. So at last I will share a Hadoop cluster tool or VM. So just open it into your PC. So it can provide the cluster. It can provide the Hadoop environment, and then you can run Hbase Hive in the top of that. I will provide the VM link. So if needed, if you are creating a multi-node machine, now it's a single node machine, multi-node machine. In that situation, you can change the host name. So host name control space set host name, the host name as master. If you are creating 3 nodes, so first name as master, second name as node 1, third node as node 2, something like that. If needed, you can change the name. Now it's not needed. Because currently we are working on single node Hadoop installation. Currently we are entering into single node Hadoop installation process. Step number 2. So step number 1, host name control, set host name, master. So if needed, you will verify VM etc/host. In that file, the name was recorded. So etc/host. So IP address of the machine, then machine name. If needed, you will record it. Now it's not needed because single node machine. So yeah, step number 2. So step number 1, naming the machine. Step number 1, just for naming the PC. So your system was named into master, and then your IP address was configured in the file vi host. Step number 2. So the Hadoop environment, which is purely depends on Java programming. Actually, you can write a program in Hadoop via Java, Python, and Ruby on Rails. So which can support Java, Python, and Ruby on Rails. But Hadoop, which developed with the help of Java. So Java installation is mandatory for running Hadoop. So the prerequisite for Hadoop is Java. The prerequisite for running Hadoop environment, which is Java. So you can download the Java software from Oracle website or OpenJDK, Sun website or Oracle website. That's not a problem. You can download the Java. So after downloading Java, so either download directly entering into a browser and download, otherwise using curl command to download the file. So after downloading Java, you can install it in Java. So just double click and install. That's not a problem. Here the CentOS is a Red Hat Package Manager. So you can install via RPM, Red Hat Package Manager space -UVH, update, verbose, and hash the file name. So the Java was installed, 100% was successful. RPM for Red Hat Package Manager -UVH for update, verbose, and hash verification, the JDK file. So the Java file was installed in your PC successfully. So step number 1 for naming your PC. Step number 2 for downloading Java. Step number 3 for installing Java in your PC. Step number 4. Step number 4. That's a core step. Step number 2 actually. Step number 4 actually. So you can create a new user for Hadoop. You can create a new user for Hadoop. So user add -d for create a new directory. The name of the directory was opt/Hadoop. The username was Hadoop. So user add space -d for create a new directory inside the folder /opt/Hadoop. The name of the user is Hadoop. So you can create a user named as Hadoop, something like a Windows. Go to control panel and create user, something like that. Now you are creating a user named as Hadoop. The base folder, something like my documents. The base folder of Hadoop is opt/Hadoop. Yes, fine. Now we are setting password. So password passwd Hadoop. So it will ask for password for Hadoop. So you are creating user and then adding Hadoop password. So step number 4 Step number 1 for naming system. Step number 2 for downloading Java. Step number 3 for installing Java using RPM command. Step number 4 for creating user. Step number 4 for creating user and password creation. Now step number 5. It's very, very essential. Step number 5. So download Hadoop file. Either using curl command or directly entering into the website and then download the Hadoop. So Hadoop 2.7.2, now Hadoop 3.1, anything, you can download the file. Hadoop 2.7.2.tar.gz, you can download the file. You can download the file from Hadoop environment. Now, after downloading Hadoop file, so downloading Hadoop file, just it's a zip file, something like that. You can extract the Hadoop. You can extract the Hadoop file. So tar xfz, tar xfz, Hadoop 2.7.2 tar.gz, tar xfz, Hadoop 2.7.2 tar.gz. You can extract the file. Yes, fine. Okay. Now your core folder is opt/Hadoop, but you are extracting file in different location. So cp is a command, copy, read file from this Hadoop folder to your user folder. Copy the file from your Hadoop folder to opt/Hadoop is the home folder of your Hadoop user. So just you can copy the file and move it to opt/Hadoop. opt/Hadoop is not a root user, so you can provide the change ownership command. So change ownership -r Hadoop opt/Hadoop. So you can give the root ownership to opt/Hadoop. You can provide root ownership to opt/Hadoop. I am repeating that again. Step number 1 for installing Java. Step number 2 for downloading Hadoop and paste it inside opt/Hadoop. Just 2 steps. Step number 1 for Java installation. Step number 2 for download Hadoop and extract and place it into opt/Hadoop folder. Yes, fine. Now, say, yes, everything was fine. Now you are entering into your Hadoop user. Now you are entering into your Hadoop user. So SU for super user space hyphen space Hadoop, your username. SU space hyphen space Hadoop. So it will automatically enter into the prompt is changed into hash to $. If the prompt in hash, you are in admin mode. If prompt in $, you are in root mode. Sorry, prompt in hash, you are in root mode, that is admin mode. Prompt in $, you are in user mode. So SU hyphen Hadoop, automatically prompt was changed into $. Now I will open the file BI bash profile. BI dot bash underscore profile is something like a path setting. BI dot bash underscore profile. BI, open that file. So inside that I will type Java home path class path Hadoop home. Hadoop home is opt/Hadoop. Then common home, HDFS home, MapReduce home, yarn home, Hadoop option, common library, Hadoop. So I will write the environment variable. I will set the paths. So all those things which return in the bash underscore profile file. So once you have restarted your machine, automatically bash underscore profile file executed. Now I won't restart. So I will use the command called as source dot bash underscore profile. So it executes the file, the source command which is pasted inside the terminal for verification. Whether it's executed or not, for verification, echo Hadoop home, echo Java home. So Hadoop home is opt/Hadoop, Java home is user/java/default. It's working. So again repeating the same. Java installation rpm-uvh jdk 1.3.rpm. Second, extract the Hadoop and copy paste inside your folder. Yes, fine. Then third, you can open bash underscore profile file and then type all the environment variable. Now you can, everything was ready. Now you can enter into the core process, that is change 4 XML files. It's a core process of Hadoop, changing 4 XML files. The first XML file, which is named as core site.xml. So inside that, you will provide just a name and your HDFS environment name. HDFS:// either if your system name is master or localhost, so provide localhost :9000. It's enough. So second file, first file is core site.xml. The second file, HDFS site.xml. So the first file for core site.xml, second file for HDFS site.xml. HDFS site.xml, which plays a vital role. The main role in Hadoop, which depends on HDFS site.xml. So inside that, you will provide name of the name node as well as name of the data node. Please listen carefully. So here we will specify the data directory because we are using a single node cluster. So the data directory as opt/volume/data node and the name node directory as opt/volume/name node. I will create 2 folders. One is opt/volume/data node. Another one is opt/volume/name node. If 2 folders are acting as 2 nodes. So I will configure it inside my HDFS site.xml. First one core site.xml. Second one HDFS site.xml. It's modified. The third one, I will create two folders. Make directory -p opt/volume/name node. Make directory -p opt/volume/data node. I will change my ownership. Change ownership as a root Hadoop Hadoop opt/volume. Now the root ownership which is given to my Hadoop environment. So everything was fine. Now my system was ready. If needed, we will modify MapReduce site.xml. Now it's not required. Yarn site.xml, it's also not required. We will change 4 XML files. One which is called as core site.xml. Second one which is called as HTFS site.xml. Third one which is called as MapReduce site.xml. Fourth one which is called as yarn site.xml. So you will modify all those 4 files. After that, you will type a single command. Before that, we will change Hadoop environment.sh file. Just open etc/Hadoop environment.sh file and change Java home as user/java/default. So step number 1, Java installation. Step number 2, download Hadoop, extract and paste it inside your folder. Step number 3, edit bash profile. Then next step, you can edit 4 XML files, core site.xml, HTFS site.xml, MapReduce site.xml, yarn site.xml, 4 XML file. After that, you are opening the shell program, that is Hadoop environment.shell, and change Java_home user/java/default. Now everything was ready. Everything was ready. So you can work on that environment. So just you can type the command HTFS name node format. So name node was formatted. HTFS data node format. Data node was formatted. So now you can type either start dfs.sh, stop yarn.sh. Otherwise, very easiest command. Start -all.sh. Start -all.sh. So start -all.sh, which run all the services of Hadoop, and then the service was started. Start -all.sh, all the service was started. So just place JPS, Java Positioning System. Just place JPS, Java Positioning System. So it will display data node is running, name node is running, JPS is running, secondary name node is running, resource manager is running, node manager is running. So all these complete services was running and ready. So now your Hadoop installation was completely ready. In the top of that, you will work either on Hadoop commands or on HTFS command or on MapReduce program or install Hbase, install Hive, Zookeeper, pick and everything. All those easily executed in the top of this environment. So the complete process, the complete entire process, I will create my own operating system, something like I will create deploying an operating system CentOS. In the top of that, I will install this single node Hadoop and properly configured, and required files are placed inside documents folder, and just open that file in your virtual box. Everything it's ready for open in your PC. So 1 second. So this is a basic overview of Hadoop and HTFS installation. After installation, you will verify HTFS DFS for create a directory. So directory was created in HTFS environment. HTFS DFS - put a file. The file was uploaded into HTFS environment. HTFS DFS create directory. A directory was created. HTFS DFS put a file. The file was uploaded into HTFS environment. So it can easily execute it. HTFS environment. 1 second, please. So I will summarize the things for the first session. So after that, we directly enter into a demo on Hive and Hbase with the help of a small VM demo for Hadoop and HTFS, Hbase and Hive for next 1.5 hours. So just I summarize my things. So big data, it's amount of data just beyond technology's capability. The data which is called as big data. So because data size was very larger, so it need a proper environment for managing this data. So one of the excellent framework which is named as Hadoop. The Hadoop which comprises of two core components named as HDFS and MapReduce. Then in addition to that, there are several set of additional tools developed by each and every organization. Google developed their own tool called as Pick. Facebook developed their own tool which is called as Hive and Hbase. So all those tools use their own approaches. So at last we are entering into small demo on Hadoop. So we'll start a small demo on Hadoop VM. So I will share my Google Drive. So the drive which comprising of two VM file, two OVA file. So one just for a CentOS operating system. Then inside that, all those Hadoop components are configured. If needed, you will try to install the same. The second one, already installed Hadoop VM. So now I'm opening, already installed Hadoop VM. So now the file, I hope the screen is visible. Sir, screen is visible? Julius, sir?
Yes, sir. Kekda?
Yes, screen is visible?
Screen is visible, sir.
Okay, thank you, sir, thank you.
Okay, sir.
Yeah, now the virtual box, inside virtual box, I'm opening my Hadoop VM. Just open a console. So the command prompt was open. Just I'm opening a console. So inside that, I will entering into root user. So SU. So the password is K7 cloud. So it entering into the user environment. CD documents. ls cd documents. ls cd K7 cloud. ls. Inside that, all the required files are stored inside K7 cloud. Documents inside K7 cloud. So if you are downloading the VM, all the required files are stored inside K7 cloud. Inside documents inside K7 cloud. So in addition to that, I'm creating a manual for NEC manual as well as K7 cloud help file. So inside that, all the text tutorial. So CD K7 cloud help. So inside that, all the experiment help tutorial is also available. So if needed, you will utilize the same. So now I'm exit the same. So everything Hadoop installation was already ready. So I'm entering into su-hadoop. So it's a virtual machine. The complete Hadoop installation was ready. So I'm directly entering into su Hadoop. So the prompt which is changed into $. So now the Hadoop user was ready. So we'll start the service, start -all, sorry, without space, start -all.sh. It will start all the services. So name node started, secondary name node, data node, and resource manager and activity manager. Entire thing was started. So the complete thing which is available in that VM. So you can directly start the VM. So the entire thing was started. Initially the name node was started. Now we're starting a data node. So the data node was started.
Sir, actually your typed content is not visible, sir.
Oh, sorry. Now is it visible?
Yes, sir. Yes, sir.
Okay, thank you. Now we're starting secondary name node and yeah. So yes, now the prompt was ready. So I will place CLS. So yes, now all those services started. For verification, I will place JPS. So the entire VM is already ready. So Java was installed, Hadoop was installed. All the 4 XML files are configured. So here data node was running, name node was running, secondary name node is running, resource manager is running. So everything was running. So now the HDFS environment is ready. So for verification, I will open a browser. I will open a Firefox. I will open a Firefox browser. Yeah, it's opening. Please wait for a second. Yes. So in that Firefox browser, I hope the browser was visible. Local host colon 570. I'm type the same, then press enter. Localhost colon 570. So press enter. Yes, Hadoop is running. So I place utilities, browse the file system, and then go. Yeah, there is nothing is placed in my HDFS environment. My HDFS environment was empty. Now I will create a new directory on my HDFS environment. So just I'm typing the command HDFS dfs -mkdir. I will create a directory named as KServe. HDFS DFS Hadoop distributed file system -mkdir KServe, which will create a directory on HDFS environment. So in the name KServe. Yeah, just verification. I am entering into the browser and then click the button go. Yeah, the KServe folder was created. I hope my screen is visible. Just I can create HDFS DFS mkdir KServe. So the KServe was visible. So just open the VM, just download the VM from my Google Drive and then open it in VirtualBox. The password is K7 Cloud, K7 number and then cloud. Then you can enter into the prompt and then start -all.sh. The entire service was started. Now the directory was created. Now I will create a new file named as cat, create a new file named as a.txt. So inside that I will type, this is my first Hadoop project, something like that. I will type something like that. Then I will press Ctrl+Z. So now I have created a new file, cat greater than a.txt. For verification, cat a.txt. So yes, this is my first Hadoop project. Yes, file created. Now I will put that file into my HDFS environment. So again, I will type HDFS DFS hyphen put my file name, that is a.txt, to my directory kserve/a.txt. So the source file a.txt, which moved into HDFS environment inside the folder kserve a.txt. Yes, enter. Now the file was uploaded into HDFS directory. Hadoop is supported for larger file. It's very smaller file. So even if it takes 64 MB, a block size. Yeah, yes, file was uploaded. For verification, I'm entering into the browser and then click on that folder KServe and then 128 MB. Yeah, because recent Hadoop, yeah, block size was 128 MB. Even original size was 32 bytes. But it takes 128 MB and replication was 3. So for managing larger data, we need more and more storage for replication also. So now the file was a.txt. The file was saved. Yes. For verification, I will place HDFS, DFS, then -ls. Sorry. -ls/ksub, which will list all the files available inside the folder named as ksub. The ksub folder which comprising of only one file, HDFS ksub folder which comprises only one file named as a.txt. Similar way, delete command, all those things are same. So now the HDFS environment was ready. Inside that, we will work on either for MapReduce and Hbase and Hive. Everything was running inside this Hadoop framework. So I will entering into small explanation on Hive and Hbase. After that, we are entering into them. So we are entering into not only SQL data. It's not SQL. It does not mean like that. So it's not only SQL. It's not a sequential database. It's non-relational database. Non-relational database. So why NoSQL? It manages very large amount of data. It can manage big data in an efficient way. Then which can have a dynamic schema. It's a column-based approach. Auto sharding, replication, and the horizontal scalable. It provides excellent horizontal scalability. So it's the greatest advantage of not only SQL database. Currently, many of the organizations, they are following not only SQL database. So not only SQL database, it's a non-relational DBMS. It does not require a fixed schema. It avoids join query. It's used for big data for real-time web applications. Companies like Twitter, FB, Google, they manage their terabyte of data via this not only SQL database. So even scale up, vertical scale up, which need a huge expensive RAM, expensive CPU, expensive hard disk. But as a scale out mechanism, that is horizontal scaling, which achieved via a commodity hardware. So currently all those organizations, they are following scale out, not scale up. Scale up in the sense expensive, cost investment is needed. More RAM, more CPU, more hard disk investment. So it's very high. So we are following scale out methodology for horizontal scaling using a commodity hardware to build an excellent database, not only SQL database. So I will, afternoon session, it's very hard to explain theorem. Anyway, just for one and only theorem. So CAP theorem. So C for consistency, A for availability, P for partition tolerance. C for consistency, A for availability, P for partition tolerance. You can achieve any two. All those three is not possible. I will give an example too. So consistency. So all the servers, for example, I have three servers. For example, I have three servers. I am requesting a data from any one of the server. I am requesting data from any one of the server. The server provide a correct result. For example, I am viewing a cricket score. System 1, system 2, system 3. All those three systems are provide the correct exact cricket score on that particular time. So that's called as consistency. So correct cricket score was provided. That's termed as consistency. Availability. So I am requesting a data, whether it's updated score or not updated score, it's not a matter. But it provides the information immediately. That is availability. So please again repeat again. Consistency. I am requesting a cricket score from 100 servers, any one of the server. The server responds the correct data, updated score. That's called as consistency. Availability. The server responds the data, but whether it's updated cricket score or not, it's not a matter. It responds. That's availability. Partition tolerance. The data are splitted into n number of devices, and if one node fails, tolerate or isolate the device and provide a service. So disk management. So achieve all the three, it's not possible because I'm giving example again. Consistency. If you are requesting cricket score, in that time cricket score is updating in all the machines. So you can wait for some time and then provide the data because the updation work is going on. So please wait. Then availability which fails. If it provide not updated data, then consistency fails. So again repeating the same. So 100 system which providing cricket score. You are requesting cricket score from one machine. So in that time, the cricket score is updating on that machine. So please wait, the score is updating. So You can wait in the sense availability was down. It provide wrong data means consistency was down. So you can either achieve consistency or availability. Any one of these things was possible. Okay, fine. So either you can achieve consistency or availability. So now consistency and availability, both the thing achieved via RDBMS. But in big data, either we achieve consistency and partition tolerance or availability and partition tolerance. So not only SQL database which provide AP, that is availability and partition tolerance. So please, availability and partition tolerance which achieved via Cassandra, DynamoDB, Cassandra, these are the excellent databases. Now many of the organizations, they are uses the same. Consistency and partition tolerance, MongoDB, Hbase, Hive. So these are the consistency and partition tolerance. Normal RDBMS, which performed via availability and consistency. Normal structure query language. Okay. So in that document model, which comprising of 4 types, relational, key value, column oriented, and document oriented, we will discuss later. So either you will achieve in unstructured data is concerned or big data is concerned, either you will achieve availability and partition tolerance or consistency and partition tolerance. So consistency and partition tolerance in the sense it's Hbase. Availability and partition tolerance, the example was Cassandra as well as DynamoDB. So what is not only SQL database? We choose to provide high scalability, big data capability, easy replication, fast performance, high availability. So normal SQL database, it's relational database, it uses analytical tools like OLAP. But in not SQL database, it's column family. Here it's row-based approach. Here it's a column-based approach. Otherwise, graph-based approach. Otherwise, document-based approach. Otherwise, a key value type. So not only SQL databases, which categorized into 4 types. One which will be called as column family approach, that is Hbase. Graph-based approach, document-based approach, and key value approach. So in normal RDBMS concept, we will use explicit schema. So you will write a query and then call that same. In not only SQL database, you will use a implicit schema. So in 2009, now also NoSQL was reintroduced. Yeah, please see here. Please see the picture. Please see the picture. A table of data center. So you can split it into row 1, row 2, row 3. Row 1, row 2, row 3. The row oriented database. Here column 1, column 2, column 3. That is column based database. So the table, if it's row oriented for RDBMS, if column oriented, which is called as not only SQL database. If it's row oriented, which is called as RDBMS. If it's column oriented data split up, which is termed as not only SQL database. One second. Yes, please see the picture. A column database example. A column database example. So the row oriented data, which is placed in the top. So ID, name, grade, and GPA. So a common identity is needed, a common key is needed. So in that situation, ID and name are grouped, first column. Second column, ID and grade are grouped. Third column, ID and GPA are grouped. Based on key ID, the data was split into column oriented approach. The based on ID, based on row ID, the column was separated. Name, grade, as well as GPA. That is column database. So each and every column is stored in a separate file. I'm giving another example again. A column space. I'm giving example. User profile. User profile is example. The Bob user profile, which comprises of email address, is a column with ID. Gender is a column with ID. Age is a column with hashtag. So, but Brittany is another user they are having their profile having email address and gender only. So it's a column-based approach. So if it comprising of a column data, it added. If it's not comprised, that's not a problem. Then Terry, email address, country, and hair color, something. So an additional column was added. So this is a column-oriented approach. So each and everything is stored in a separate file. So if user requested based on the query, which can merge and provide the data, that's a column-oriented database. That's the approach called as column-oriented database. Whenever a column family needed, we can add a column family. If it's not needed, we can omit that column family. That's the approach which is called a column-oriented database. So I am giving example. Column. So based on row key, each and every column which is separated. So based on row key, each and every column which is separated. So now we are entering into not only SQL database. So this is a small overview. It's a column-based approach. It's used to non-relational database. So now the two core components for the today's session. One which is called as Hive, the second one which is named as Hbase. So now we are entering into Hive. Hive is a data warehouse infrastructure tool. It's a data warehouse infrastructure tool to process structured data. To process a structured data in Hadoop. So Hive is a data warehouse infrastructure tool to process structured data in Hadoop. It resides in the top of Hadoop. So Hive, which resides in the top of Hadoop. So Hadoop framework in the top of MapReduce, in the top we can running on Hive. So initially the Hive was launched by Facebook. So Hive 2 initially launched by Facebook. After that, which also provided to Apache Software Foundation. So it used by different companies, Amazon for Amazon Elastic MapReduce. So it's an excellent tool. So Facebook for managing greater than 950 million user, greater than 500 terabyte data, greater than 70K queries, so greater than 300 million photos. So the one and only solution was Hadoop and MapReduce. But the problem was user only know SQL. Their programmers are not known about how to program in Python or Ruby or Java. So in that situation, Facebook creates a framework called as Hive. So table partition, schema flexibility, EC plugin, JDBC, ODBC, Hive query, essential type formats. So it's easy. So Hadoop is ready. MapReduce is the Java program. So you can create a framework in the top of that named as Hive. You can write a query automatically converted into Java program and run on HDFS environment. That's all. Why, if you are writing Java program, so because of Java program, you are writing query automatically converted into Java program. It performed via the framework named as Hive. So it's an example. So student detail, it partitioned into department CSE, civil and electrical. Bucket 1, bucket 2, bucket 3, bucket 1, bucket 2, bucket 3. All the student information are stored. So column-based approach. That's all. You can create a bucket for each and every department. Inside that, you will provide student detail in a separate file. That's a column-based approach. Hive. So I'm giving a small Hive demo. So open the same VM and then just type the Hive. So Hive shell was open. So just use a sample query, like a same SQL query. Nothing new, same SQL query. Create table name. So please see that. Create database company. Create database company. So which will create a database. It automatically create a Java program and running in the top of MapReduce. That's not a problem. Now the company was created. Show databases. Show databases is a command. SQL Hive QL here. SQL here which running in the top of Hive. So which is called as Hive QL, Hive query language. So which is termed as Hive query language. So create database company, show databases, not database, databases. So we choose to list of available databases. Please see the screen. Create database company, show databases, which list available databases in my Hive. So one of the database now created named as company. Yes, database was created. Now use company. So now you are entering into that database. Something similar like SQL query. So, but it's running in the top of Hadoop for managing unstructured data. So use company. So now we are entering into company database. Now the next query. Create table. Please listen carefully. Create table employees. I am creating a new table. Create table employees ID integer, name string, country string, department string, salary integer. I am creating a new table. Name of the table was employees, which comprising of 5 column. The first column is ID, the second column is name, the third column is country, the fourth column is department, the fifth one is salary. Now the data was delimited by the format specifier as hyphen, otherwise comma, anything. So row format delimited fields is terminated by hyphen. Please see here, create table employees inside Hive query. Create table employees, ID integer, name string, country string, department string, salary integer. Row format delimited by hyphen. Now a table was created. Now a column based table was created. So it create a folder named as company. Inside that, which create a record named as employee. Inside that, ID, name, country, department. So 4 file was created. 4 column based file was created. So inside that you will put your data. Yes, that's all. So first one, create database name, which create a database. Show databases, which choose to display list of available databases. Then now use database, use company, then you are using that database. Now create table employees. So it can create a column based database. Inside that it will create separate file for data management. Now please see here, please see carefully. Load the data. I am having a file. Inside that I will have the data 1 hyphen something name as Raja hyphen country department salary. So country as India, department as CSE, salary as 1000. So I am having a text file. I am having a text file. The text file named as employees.txt. I have a text file named as employee.txt, which comprising of 1 hyphen Raja hyphen India hyphen CSE hyphen 1000. Similar way, another data. So all those data are stored in a file named as employee.txt. I will overwrite that data. I will load the data into my table named as employees. So load data in path slash Hadoop slash employee.txt, overwrite into table employees. Again repeating the same, please listen carefully. Load data in path Hadoop slash employees.txt. So my file employee.txt, which comprising of data, that data which will be loaded into employee table. Yes, fine. How? So the file was properly formatted. Actually, this is unstructured data. Employees.txt is unstructured data, but which is auto formatted into table. So load data in path Hadoop slash employees.txt, overwrite into table slash employees. Now, which loading a data, select star from employees. So something having 2000, something here 2200, 2500, quality engineer, record engineer, sales, and 1800, something like that. So it comprising of a data, a table was created. So I am creating database, I am viewing database, show databases. I use my database, I create a table, I load the data from my text file and then push it into my employee table. That's an example for Hive. That's an excellent example for Hive. So Hive just create table, same thing like SQL query. All those queries are insert into table name, it's working. Then delete, yes. Drop, yes. Then something like alter, yes. Update, yes. So everything was fine. All those things are common. So all are very much familiar about SQL queries. So I'm not entering into the same. Even a Java point or tutorial point is an excellent tool for helping you to guide these set of queries. So the theme was create a database, then show databases which used to list the database, create table, then load that value from text file to table. Load the values from text file to table. That's the thing. So we choose to load the entire value from employee.txt file into a table named as employees. So which will load the file. So which auto loader, which is column based approach, which entirely loaded into the file. The column based approach, the replication, then everything which managed by Hadoop and MapReduce. User, don't worry about anything. Just write a query and copy paste the content and working on that environment. That's an excellent idea behind this Hive. Because of that reason, Facebook and Amazon and all those elastic search engine, they are depending on this Hive technology. So show tables is a command which choose to list all those tables available inside my database. Show tables is a HiveQL, Hive query language query. So we choose to list all the tables which is placed inside my database. So display the data. So for example, you will view the display the structure of your table. So you will place a markup called as Hive query language called as DESC employees, which used to list the basic structure of your Hive query language. So ID integer, so DESC employees, ID integer, name string, country string, department string, salary integer, which choose to list everything in a proper way. So it's the easiest way for displaying your Hive data. It's a very easiest way for display your Hive data. So display the selected data. So similar, normal SQL query. All are very much familiar about SQL query. Select name, comma, country. Select star from employees, you choose to list all those columns. Select name, comma, employee, you choose to only list name and country. Select name from employees, you choose to only list name. So this is a display selected data via query. Yeah, normal, all those structure query language, all those query which is supported in HiveQL. Yes, fine. This is a small overview on Hive. So not only SQL database, it's a column-oriented approach which choose to manage in a non-sequential database, which follows throw data in a files. So which efficiently managing via Hive query language. So Facebook, which introduced this Hive query language, because all their developers don't know about Java programming or Ruby or Python. Because of that reason, Facebook introduced a Hive framework for query language. So HiveQL, which is similar to SQL query, you can write a SQL query in the background process, which automatically converted into Java program and then running in the top of MapReduce. So all the load balance, all the basic job tracker process, which is managed by Hadoop and MapReduce. So this is an excellent tool. So this is a small overview on NoSQL and HiveQL. Now the third one. Now the third excellent tool, which is named as Hbase. Now the third excellent tool, which is named as Hbase. So Hive and Hbase, both are Apache Foundation. So Hive is a query engine. Hbase is a data storage, particularly for unstructured data. Please listen carefully. Hive is a query engine developed by Facebook, but Hbase is a data storage, particularly managed for unstructured data. Apache Hive is mainly used for batch processing, OLAP, but Hbase is extensively used for transactional processing, wherein response type, the query is not highly interactive. So it's analytical process, here it's a transactional process. So operation in Hive are transformed into MapReduce job, but Hbase which directly running on HDFS. Please think about ecosystem. Hbase, there is no need for MapReduce. But Hive operation completely rely on MapReduce. Hive operation which completely rely on MapReduce, but Hbase operation, there is no need for MapReduce. Hive is analytical queries, but Hbase is to real-time querying process. Okay, this is a small difference between Hive and Hbase. So yeah, this is a pictorial representation, Hadoop ecosystem. So HDFS in the top of that Hbase directly working on, but HDFS MapReduce in the top of that Scoop, Hive and Picketing. So everything working in the top of MapReduce. So Hbase directly rely on HDFS environment. Hbase is a framework which directly rely on HDFS environment for managing unstructured data. It's acting as a data store. So Hbase, which also supported for general queries. So something like status, version, table help, whom. Hbase is also a database. So it supported all the database queries. So please see here. So if you start Hive, just type Hive in your shell program. Start Hbase, you will type Hbase Shell. So type Hbase Shell. So immediately Hbase was started in the open terminal and then type Hbase Shell. So immediately Hbase Shell was started. So the first markup, which is called a status. So it can view the status of the server. So one server, one is dead. So status simple and status detail. There are two options also available. You can view the status. So status markup, which used to display the status of current region servers, because all the Hbase environment which depends on node, that is region servers. So how many number of servers are available? So that details which is listed via the markup called the status. So you can give a command status which used to list number of available servers. Then the second one, version. So by default, if you type a markup which is called as version, which used to list which Hbase version we are working on. So 1.1.1. So it used to display the same. Then table help. So it used to list how to create a table, how to get a table. So everything was displayed in table help. So who am I, which used to display the username. Who am I is a markup which used to display the username and group name as well as the username as well as group name. So something which listed the same. Who am I? Then yeah, now we are entering into the table management, the column-based table management in Hbase. It's the last one, the column-based table management in Hbase. So all those markup in Hive, which also similar here, create table, list all those tables, describe, if needed, disable or enable all, enable all, drop the table, drop all, show filters. There are numerous number of filters are available because it's a column-based approach. So there is no join query are available. So you can use filters to get the data. So similar way, you can alter or modify the table, alter the status of the table too. These are some of the excellent table queries in Hbase. Excellent table queries in Hbase. Hbase is an excellent framework which directly running in the top of HDFS. There is no need for MapReduce here. It's used to manage unstructured data in an efficient way. So now I am creating a table, create table education. Inside that, I will create a column, single column named as group 99. So create education, comma is separated. So create education, comma group 99. So it create a table named as education, and then inside that which create a column family named as group 99. So for example, I will use the command list, which used to list all the available table in the Hbase database, which used to list all the available table in Hbase. Now my table was created in the name education. Inside that the column named as group 99. Now next. So describe education. Describe is a command which used to give the entire description about the column family. which used to describe entire description about the column family. So table education, it's in enabled mode, it's not disabled. The column family description, a name is GRU99. The column name does GRU99. The Bloom filter is a row filter. Here row filter is Bloom filter. There is no replication is specified. The default version number is 1. The block size was 65536. In memory is false. Block cache is true. The entire information about the column family of a table education, which is displayed. So if you can disable before deleting all the tables, you can disable it. So if needed, otherwise it's not needed. So there is an option is available, disable or enable. So disable education. So we choose to disable the table. Similar way, enable education, you can disable or enable table. Its option is available in Hbase environment. So show filters, show underscore filters. We choose to list available filters. So based on the filter, you can get the data in an efficient way. You can gather the data from Hbase because it's unstructured data. So for grouping and managing data is typical. So it provides several set of filters, column prefix filter, then timestamp filter, page filter, multiple column prefix filter, family filter, etc. etc. Numerous number of filters are provided by Hbase. So for retrieving data in an efficient way. So drop, all are more familiar about query languages. So it's not a problem. So dropping a table, drop in the sense we choose to deleting a table. So drop education, we choose to remove the table education. So alter education, please listen carefully. Alter education, with I am adding a new markup. So alter education name equal to GRU99 underscore 1, version tends to 5. Version tends to 5. So new row which is added, which is named as new row which is added, named as new row which is added, that is GRU99 and version 5. Then alter edu GRU99, then which is changed into GRU99.2 and added into GRU99.3. So anyway, alter, add, alter, modify, alter, delete here also support. Alter, add for adding a new row, alter, modify for modifying existing row, alter, delete, we choose to delete the alter, add, alter, modify, alter, delete. So both the things which is supported in Hbase. Now, how to insert the data into Hbase? How to insert the data into Hbase? So just use a markup called as put. Just use a markup called as put. So inside a column family GRU99, you can add multiple columns. So don't think about that. Here, in Hive, inside a table, you can create multiple columns. But in Hbase, inside a column family, so it's a column family 1, column family 2, column family 3. Inside each and every column family, you can create multiple. So GRU99, R1, C1, value 10. So you can create multiple columns. So it's supported. So inside column family, you can create multiple columns. So it's also supported in inside column family, you can create multiple columns. So similar way, you can delete each and every column based on row ID. Delete column based on row ID. If one row ID is deleted, all those columns, all those column files was deleted. So this is not required. So if you are willing to select query, something like a select query, here the select query which is achieved via the command which is called as cat. Select query which is achieved via the command which is called as scan. So choose to display the available data. Scan GRU99. So choose to display all the available data. Okay. So same thing, but query name was little bit changed. Create, then put, then scan. something like that, something a little bit different, but all those automatically managing unstructured data in an efficient way. So it also follows column family, and each and every column family is separated by several set of columns. So this is a small overview on Hbase. So I am summarize everything. So big data, it's amount of data just beyond technology's capability. So in that big data, the Hadoop is an excellent framework which used to manage the entire big data environment. The Hadoop, which is split into two core frameworks, one which is termed as HDFS, the second one which is called as MapReduce. In the top of HDFS and MapReduce framework, you are running several set of collection of frameworks named as Hive, Mahout, Zookeeper, then Pick, and something like Apache. There are numerous number of tools. So normally Google uses Pick Latin for their programming. Facebook uses Hive. Then Hbase is a column-based approach. So all those tools running in the top of HDFS and MapReduce. So at last, I will share a small virtual machine. Inside that, how to install a Hadoop, then how to create a basic HDFS environment based on the XML file configuration. So Hadoop environment was started. So inside that, how to put a file, how to read that file, then how to create a Hive environment as well as Hbase environment. So it's very easy. So you can download that VM and then just download Hbase file or Hive file. Then you can copy paste in the required place and then just start Hive command. Just type Hive. So Hive shell was started. You can create a query and work on that Hive environment. Similar way, Hbase shell, you can start a Hbase shell environment. So this is a small overview. So 1 second. First, Hive, Hbase, the small intro on MapReduce 2. So for example, yeah, the computation was split up. So for example, you can think about a coin deposit machine. So a collection of coin was placed either for 5 rupee, 2 rupee, as well as 10 rupee coins. So you can deposit into a machine. So how coin counting machine works. So it can categorize the coin based on face value. So first it can split all the 5 rupee coin, all the 2 rupees coin, as well as all the 10 rupee coin. So based on face value, the coin was split. So all the 5 rupees coin was collected, all the 10 rupees coin was collected, all the 2 rupee coin was collected. Then count the coins based on face value. So all the 5 rupee coin was counted, all the 10 rupees coin was counted, all the 2 rupee coin was counted, and then multiplied with the face value into 5, into 2, into 10. Then total value was resulted. So it's a real-time analogy for MapReduce. So a job client, a job tracker, as well as name node, it's a Hadoop HDFS environment. So job client can submit the job, then job tracker, which can coordinate the entire job, task tracker, which can execute the job, then MapReduce function and configuration, which is performed. So it's the idea behind MapReduce. It's the idea behind MapReduce. So the computation was split into all the nodes and process and then get the result. So step number 1, just for a few more minutes, I will complete sharply at 4:30 or 35. So job client. So step number 1, client submit the job. Step number 2, job tracker, which can find a name node for data. So 3 for task execution. 4 for task tracker to do the job. So at last reducer, which can perform the entire task. This is a basic activity. The entire MapReduce activity, which depends on 2 core ideas. One which is called as map and reduce phase. So map phase, which depends on key and value pair. Reduce phase, which depends on single key along with list of values. Single key along with list of values. So it's a basic activity. Input, we split it into pieces and then map and shuffle and then reduce. Yes, there is separate session for MapReduce. So just for a small overview, I will conclude soon. So input data. This is something deer, beer, and river. So the file which comprising of 3 lines. First line for deer, beer, and river, car, river, and deer, car, beer. So the 3 lines of data we submitted to our engine. The 3 lines of data we submitted to our engine. We split it into 3 lines. That is, a file was split into 3 pieces. Deer, beer, as well as river, car, and river, deer, car, as well as beer. We split it. Now map phase. Each and every var which added with 1, a key and value. Var is a key, value is 1. Yes, it's map phase. In shuffle, so it's aligned. All those beer, all those car, all those deer, all those river was grouped. In reduce, the count was added. The reduce, the count was added. It gets the output, the combination of everything. So this is the result. So the file was split and then processed by each and every device. For example, I have a 1000-page book. I can split each and every 10 page to 10 students, 10 or 100 students. So each and every student count the number of words. And then at last I will collect everything and then return a result in a faster manner. That's the theme. So process was split and computation was explained to everyone. How to count that computation. Process was split, data was split into devices, and computation, the process was also written in a program and submitted to everyone. And then all those people are processing the data and then return the result. This is a basic overview behind MapReduce terminology. So there are several set of research ideas behind that, because if mapper fails, then you can intermediately you can combine this car too. So here intermediate result you can optimize, so it can perform little boss faster, MapReduce which works faster. So there are several set of research is going on in MapReduce. So computation, memory tasks. So similar way there is an excellent Java program for MapReduce. So in MapReduce program is supported for Java archive. So you can generate a Java archive file and then submit it to a MapReduce deployer, so it can work. So I will complete. So it starts from overview on what is big data. So big data is amount of data just beyond technology's capability to process, store, and manage data. So one of the excellent framework for managing big data, which is named as Hadoop. The Hadoop, which comprising of 2 core components named as HDFS and MapReduce. In the top of that, we are running several frameworks. One of the frameworks named as Hive and Hbase. Hive is a query language developed by Facebook. Hbase, which is a column-based approach, which is directly running in the top of HDFS. So this is